We also have here examples, okay? And we will use these things in examples. Okay, solve the following differential equations. I think we have more space. I'll try to squeeze everything here. Okay, the first one, A, we have to solve this differential equation that is homogeneous because on the right-hand side we have 0. Okay, A, let me
Sorry,
change.
sir.
Yes?
I see you didn't record the video also.
Yeah, I forgot to record, but now I started recording. Okay?
Yes, sir. Yes, sir.
Yeah, I forgot actually, unfortunately. Because David, you didn't tell me, it's your fault. Okay, I just started recording, all right. And this thing is also used a lot. If you didn't understand well, we should just sit and follow the steps, and especially using this identity or formula, okay, and how we get this one, how we are writing. Actually, this is the solution, and since here it has this imaginary number that I, right, I'm just changing this into, I'm writing this without using, what is it, this imaginary number. And when we do so, we will have cosine and sine in the solution of this differential equation. Okay, and you see here, usually most of the time you will see that every solution of the differential equation, it contains exponential function and cosine function or sine function or combination of these things. Okay. All right, let's see these examples. Example 1, guys, I will stop at around 11:45 or 14. Okay. Second order differential equations. Example 1. The first one, immediately, I don't have to write the copy the question here, right? Just immediately let's write the auxiliary equation. Our auxiliary equation is 2m squared minus 5m minus 3 is equal to 0, right? It is auxiliary equation of this differential equation. From here, delta is equal to 25 plus 4 times 2, 8, 8 times 3, 24, which is equal to 49. So what is M1? M1 equals 5 plus 7 over 2, that's equal to 6. And M2 is equal to 5 minus 7 over 2, that's equal to negative 1. Right? Actually, it doesn't matter which one you write first. Then the solution of this differential equation, dot, 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 that's equal to C1 times, let me just write it first, e to the power minus x plus C2 times e to the power M2 is M1 is 6, that is 6x. That is the general solution of this differential equation. Okay, that means that here we have a set, let's say all the solutions here. If we just pick any solution from this S, right, it can be written in this form. It can be written that y will be C1 times e to the power minus x plus C2 times e to the power 6x. Okay. Any function of this form will be solution to this differential equation. B, let's solve B here. B, its auxiliary equation is m squared minus 10m plus 25 is equal to 0, right? So from here, and it's just, the perfect square, we can write it as m minus 5 squared is equal to 0. That means that m1
Sorry,
equals
sir.
m2 equals 5. Yes?
Sorry, sir. I think like we have for M1 and M2, we have to divide by 4 because 2A. A is 2, and we take it multiply by 2.
2a. Thank you.
Yeah.
4. So at that time, this will be 3. and this will be minus 1 over 2. Okay, so here at the time this will be minus 1 over 2x, right? And here we have 3x. Okay, and also here 1 over 2 and 3x. Okay, fine. Thank you very much. And example B is equal to 5. Then the first solution, y1 will be e to the power 5x, right? And the second partial solution will be e to the power 5x. And what we have here, we have x. Okay, if you just follow the step, we will get this x. Okay, and that's why here the solution will be, the general solution of this differential equation will be c1 times e to the power 5x plus c2 times x e to the power 5x. How about in question C? And direct is also the solution is, what is this? M squared plus 4m plus 7 is equal to 0. Okay, so this union equals 16 minus 28, that's equal to minus 12, right? So m1 is equal to, what is it? Negative 4 plus square root of minus 12 over 2a, that's equal to 2. And if you divide by 2, it is negative 2 plus, and here we have 4 times 3, 2 to cancel each other, 3 left, right? So here we have I square root of 3, right? So the square root of negative 1, it is I. And immediately we will get the second solution as minus 2 minus I square root of 3, right? Then what is the solution of this differential equation? Dots, dot, dots. The y of x is equal to, this real part is negative 2, e to the power minus 2x times, here we have c1 times cosine of square root of 3x plus c2 sine of 3x. Oops. Sorry. Okay. We have not enough space. That is the solution of the given differential equation. Any question? No question. All right, guys, continue. It's very simple, not very complicated. Just you need to practice a few questions and you'll get the idea. Example 2, that is initial value problem. Solve this differential equation, 17y equals 0, and initial conditions, y sub 0 is equal to negative 1, and the y prime of 2 is equal to, here, I forgot to write this one, that's equal to, what is it? At 0 is equal to negative 1, at 0 is equal to 2. So here we have 0 is equal to 2. Guys, let me just correct this immediately. Technical mistake. That's correct, because otherwise if the question is wrong, we'll have a problem. So this initial value problem, first we should just ignore this and try to find the general solution of the differential equation. And using these conditions, we will find those constants, right? C1 and C2. To do this one, immediately this auxiliary equation will be 4m squared plus 4m plus 17 is equal to 0. Guys, can you just give me 1 minute? We'll continue after 1 minute.
Hello guys, welcome to our YouTube channel. Guys,
All right, Mr. David, I'm back. So that is our auxiliary equation, right? 4m squared plus 4m plus 17 is equal to 0. And when we solve this discriminant is equal to 16 minus 4 times 4 times 17, which is equal to, where's our calculator? 16 minus 16 times 17, that's equal to minus 256. That is minus 16 squared, right? So m1 is equal to minus 4 plus minus square root of minus 16 squared over 2 times 4, which is equal to, if you simplify this, here we have minus 1 over 2 plus minus, and here we have 16 comes out, right, and 8. So here we have 2i. Okay, plus minus this. Actually, here we have m1 and m2. Right. Now we can write the solution. This y of x will be equal to e is a power. Here we have the real part is negative half minus 1 over 2x times c1 times here we have cosine of 2x plus c2 times sine of 2x, right? And that is the general solution. Now, using these different conditions, we need to identify this c sub 1 and c sub 2. From the first one, y of 0 is equal to, this one is equal to 0, this one is equal to 1, so here we have c1 times e to the power 0, that's equal to 1, so that's equal to negative 1. So the value of c1 is equal to negative 1 for this initial condition, right? And now the derivative of this function at 0 is equal to 2. To do this one, we have to differentiate this, right? And when you differentiate and substitute here, we will get this 2. Okay, we will do like this. This y prime of 0. Why can I do that? Because first, if we differentiate this, right, and substitute this, we will get equals minus 1 over 2 times e to the power, and here we have minus 1 over 2x, so that's equal to 0. And inside we are not differentiating, so when the 0 is equal to 0, when the 0 is equal to 1, c1, right? Because this is one u times v, u prime v plus u v prime, right? When we just differentiate this, the first part, and substitute in 0. Plus the second part is e to the power this, so that is e to the power 0 times. Now if you differentiate this, it will be sine, right? Sine function. Because of the 0, it will be 0, so no need to write this. And if I differentiate this, it will be cosine, so here we will have 2 times c2 times cosine of 2x, so that's equal to 0. So this is equal to 2. Now if I just simplify this, that's equal to 1, and c1 equals negative 1, and multiply this, if we have 1 over 2. Plus, this is equal to 1, right? So here we have 2, this is equal to 1. 2 c sub 2 is equal to 2. Now from here, c sub 2 equals, that is 3 over 2, that's equal to 3 over 4, right? So then the solution to this initial value problem is y of x is equal to e to the power minus 1 over 2x times c1 is 1 cosine of 2x plus 3 over 4 sine of 2x. Okay? Gentlemen?
Yes, sir.
All right, you are so quiet. Maybe you understand everything, or you understand everything. Let's continue. Two equations worth knowing. The following two equations are very important in applied mathematics. And here, k is a real number. And we are going to see these equations a bit later. And you will see that it's used a lot. I don't know, we can reach the topics or not, especially in wave equations and heat equations or heat diffusion problem. And in most cases, actually, some kind of heat diffusion problems, when you just simplify and solve it, we will have this form, or we will have this form. Okay. And since it is related to our current topic, that's also we're going to discuss these things. Now, just suppose that we are given these two differential equations. These are two different differential equations. First, we have to solve this, and when it is minus, we have to solve this. Okay. On purpose, here they write square because we are sure that the coefficient of y is positive here, and here the coefficient of y is negative here. Okay. Depending on the problem, and actually it appears in applied mathematics, and also we'll see this. You'll see it in some exercises. The first one, right? Now, if you just form our auxiliary equation, let me draw a line. What is it? That is m squared. This is our first equation. This is our second equation. Okay, the first one, we are just considering the first one. M squared plus k squared, right, is equal to 0. Now, from here, what is m? M equals plus minus k. No. Sorry. Here, m squared is equal to minus k squared, right? Now from here, m is equal to, what is it? Plus minus I k. Because here we have square root of -1, right? That's equal to I. M squared is plus minus I k, right? At the time, what will be the solution of this equation? The solution will be y of x will be c1 times cosine of kx plus c2 times sine of kx. And next time, if you just see this equation, we don't have to solve this. Immediately write that it is cosine of kx plus sine of kx. Right. How about the second one? If you solve the second equation, and here we have m squared minus k squared is equal to 0, right? From here, m equals plus minus k, right? Or if you just write the solution, then y is equal to, or y1 is equal to e to the power kx, and y sub 2 is equal to e to the power minus kx. Right? All linear combination will be the solution. I can just write here that y of x is equal to c1, 10 minutes left, c1 e to the power kx plus c2 e to the power minus kx. That is the solution. Okay. Now I can just write this in some different form. And if you remember, how did you define this sinh of x? Or sinh of kx, doesn't matter. That is equal to e to the power x minus e to the power minus x over 2. Okay, it's just new notation. There's nothing new here. Because a lot of times this appears, that's why in short form, mathematicians introduce this new notation. And how about cosh of x? That's equal to e to the power x plus e to the power minus x over 2, right? And here we have 1 over 2 this minus 1 over 2 this. So now in the first case, if I choose one of the solutions, for example, let's say c1 equals 1 over 2 and c2 equals, what is it? Here we have minus 1 over 2. And when we get so here, we get one solution, right? One particular solution. At the time, we will have here e to the power kx plus e to the power minus kx over 2, which is equal to cos kx. And if I substitute here again in the case, let's say C1 equals 1 over 2 and C2 equals 1 over 2, and substitute here, we get another solution, particular solution. That's equal to, if you substitute here, 1 over 2 is the power kx minus, well, let me, okay, here we have minus, then here we have e to the power kx minus e to the power kx minus kx over 2, which is equal to sinh of kx, right? Now this is also one particular solution. This is also one particular solution, right? You can find particular solution in this way or also another way. Now all the linear combination, also this stuff gives us, what is it? The general solution of this equation. I can just write here C1 times this plus C2 times this is equal to, I mean, it gives us the solution of this one. Let me just write here. Then solution of this equation will be C1 times cos x plus C2 times sinh, here we have kx. Okay. Yeah, you may wonder why we are writing in this form. This cos and sinh, these are also linearly independent functions. As I say, here we have cosine of x, sine of x, and this one is cos x and sinh x. It's easy to memorize. It's just different version of the solution. Actually, they are the same thing, exactly the same thing. They produce the same values. They're just writing in different forms, so it's easy to maybe memorize. Sometimes it's easy to write this in this form, okay? But actually, if you want, write it in this form or in this form. In some problems, they prefer to write the solution in this form using this hyperbolic functions. We call them hyperbolic functions. Okay, guys, let's generalize this and finish today's class. All right. Higher order differential equations. In general, to solve an nth order differential equation, 1. And if you remember what is 1, that is a sub n. Y is differentiated n times, right? Nth order derivative of y, and just continues like this. To solve this one, actually we need to solve this nth degree polynomial equation, and that is the auxiliary equation of equation 1. Okay. And to solve this one, when it is linear, we know how to solve this. When it is quadratic, we know how to solve this. When it is cubic, it is not so easy, either using formula or usually if it is higher than 2, we prefer to solve this, what is it, by factorization. In general, it's not so easy, but usually in this course, when I ask a question, I will just ask the question that is easily solved, this polynomial equation. But factorization, even it takes time because it has 3 roots. And at the time, if all the solutions are real, at the time the general solution will be y equals, from the first one, m1 e to the power m1x, the second one m to the power x, and nth root is m sub n x, right? And all the linear combinations of this fundamental set of solutions gives us the general solution of differential equation 1. Okay, and when m1 is a root of multiplicity k of an nth degree auxiliary equation, what does it mean? It means that this one is our polynomial equation, let's say p of x, right? When I just write this polynomial equation here, okay, when we factorize this, we have this kind of thing, term here, x minus m1 to the power k times and continuous. Here we have some other polynomial equation. I can factorize in this form. And here it says that nth degree auxiliary equation and roots of multiplicity k. And this one is multiplicity k means it has this m1 but actually I can just write this one as k times, right? X minus m1 times x times m1 times x minus m1. So we just call this a multiplicity or algebraic multiplicity, okay? And if it is 2, we call this repeated roots, right? If it is 4 at the time, it is 4 actually, for example here, x minus, let's say 2 to the power of, not x, m, the power of 4 is equal to 0. And that's, assume that this is the auxiliary equation of fourth order differential equation. At the time, the first one will be e to the power 2x. Second one will be x times e to the power 2x. Third one will be ex squared times e to the power mx. And fourth one will be x cubed e to the power mx. And how we are finding this? By reduction of order using this method. If I know this one, the first one, right? The first solution will be y sub 1 will be e to the power 2x, right? All right, 2x. And I will look for the second one as u times y1. When you solve this, you will actually already show that this u will be x. Now to find u y sub 3, I will just use, let's say this is u1 and u2 times y2. And when you just calculate this, you will see that this u2 will be x squared. Okay, in this way we can produce some other solutions. Okay. We have third order. It's almost time. Yes, guys, thank you very much. One important notice, guys, next week is, I don't think you are going to have midterm next week. You are going to have class. First, I have to finish chapter 4, then you will have midterm, okay? Tomorrow is holiday, so I will not be able to teach, but we will do compensation class. Either you want to come and we will meet together, or I'll record the video to our lesson and put it on YouTube, okay? And you will just watch yourself and study yourself. Okay, but when I'm just recording, I will let you know the time. If you want, you can just join the class or you can watch later. Okay, guys, thank you very much. That's enough for today. Goodbye.
Goodbye, sir.
Bye-bye.
Goodbye, sir.
Bye, teacher.
Yeah, enjoy your lunch, guys.
See you tomorrow.
Yeah. Tomorrow is holiday. No class tomorrow.
Yes, sir.